Hello, in this video I'm going to talk about truth functional equivalence and work through a couple of problems from practice problem set 3-2. Truth functional equivalence is a relationship that obtains or fails to obtain between truth functional statements. This is not yet a validity test or anything of the sort. It's really preliminary to that. It may happen at times that some of you are working together in groups on translating something from English to the language of truth functional logic, and you come up with different translations from one another. And you wonder, well, is this a difference that makes a difference, or could they both be correct? The question boils down to, are the translations truth functionally equivalent to each other or not? Do they have the same meaning, so to speak, within the language of truth functional logic? The same meaning is a really imprecise way of putting the point. Given that this is truth functional logic and it's all got to do with truth conditions, statements count as truth functionally equivalent to each other if they have the same truth conditions. That is, if whatever would make one true also makes the other true, and whatever would make one false also makes the other one false. If they don't have exactly the same truth conditions, then they are not equivalent to each other. The way we test for this is by using a truth table, because the truth table will give us all the possible combinations of truth values for the variables within the statements we're testing. That means that when we apply the definitions of truth conditions, we'll get all the possible combinations of truth values for the statements we're testing. And if those truth values are the same on each and every row, then the statements are equivalent. If they're not the same on each and every row, if there's a difference on even only one row, then they are not equivalent to each other. Let's consider just number one to start with, which is two statements, negation sign, open paren, P wedge Q, close paren, and negation sign P wedge, negation sign Q. It wouldn't surprise me if students working together in groups on translations, if one student might come up with that and the other student come up with this for the same English sentence and wonder, could they both be right? Is there any difference that matters? Well, let's find out. Here's how we're going to find out. We will begin by making our reference columns. And this is the pattern that we always use when we're setting up reference columns with two variables. Now, when I look at the first of these, I see that it's the negation of a disjunction. Because the negation sign is outside of parentheses, it applies to what's inside parentheses taken as a whole, and that happens to be a disjunction. So to figure out the truth value of that negation, I'm going to need to know the truth values of P wedge Q. Looking at the second of these formula, it's a disjunction, and each disjunct is a negation. To figure out the truth values of a disjunction, I need to know the truth values of each of its disjuncts considered individually. So basically I'm making what are going to work like as extra reference columns here. Let me put a little asterisk on top of the two that we're testing. So, starting with P wedge Q, we'll just fill out that column by applying the definition of truth conditions for disjunction. Disjunction is false if and only if both disjuncts are false. You see we only have that on the last row. So P wedge Q is true every place except the last row. Moving to the next column here, well, that's the negation of what we just did. So it's going to be the opposite of what we did under P wedge Q. In other words, 3 F's and a T at the bottom. Turning to the next column, well, that's the negation of P. So I just look at the P reference column and I write the opposite. Under the negation of P, so instead of TTFF, I have FFTT. Apply the same principle here to negation Q, except now it's the Q reference column where we're looking. And under negation sign Q, we get the opposite of what we had under Q. So we get FTFT. Now these two columns that we just did give us the information we need to do the last column, because this is a disjunction. One of its disjuncts is negation sign P, the other disjunct is negation sign Q. So it's the negation sign P and negation sign Q reference columns where we're going to be looking to get the truth values of the disjuncts. Disjunction again is false. If and only if both disjuncts are false, well, that's what we've got on the first row, but we do not have that anyplace else. So this disjunction is false on the first row, true every place else. Now compare the two that we were testing for equivalence. You see they don't have the same truth values on each and every row. That means that different truth conditions, different situations, can affect their truth values differently. These are not equivalent to each other. And no, they would not both be the correct translation for the same English statement. All right, I want to turn now to number 8 so that we do an example with 3 variables. That is, let's see, P ampersand Q inside of parentheses followed by arrow R, and then R wedge, negation sign, open parentheses, P ampersand Q close parentheses. All right, we've got 3 variables, so I'm going to have to set up the reference columns following the convention that we always follow for 3 variables. Under R, I switch T's and F's every single row, and we have 8 rows. Under Q, I switch T's and F's every 2 rows. And under P, every 4 rows, I switch from T to F. Now, let me see what information I'm going to need to figure out the truth values for these. The first of them is a conditional. That's because the arrow is the connecting sign outside of parentheses. And to figure out truth values for a conditional, I need to know the truth value of the antecedent by itself, which is P ampersand Q. I'm also going to need to know the truth values of the consequent by itself, but that's simple, that's R. So its truth values are just right here in a reference column already. Now the second of these that we're testing is a disjunction. I know that because the wedge, which represents disjunction, is the connecting symbol outside of parentheses. To figure out the truth values for this disjunction, I'm going to need to know the truth values for each disjunct by itself. One of them is simple, so there's no need to make any extra reference columns because there's already truth values for R by itself in a reference column. I am, however, going to need to know the truth values of the negation of P ampersand Q. I'm going to be making a reference column for P ampersand Q there, but let me make one here for its negation. Okay. We'll start first with the P ampersand Q column. We're simply there applying the definition of conjunction because this has an ampersand, and ampersand represents conjunction. Conjunction's true if and only if both conjuncts are true. P is one conjunct, Q is the other. You see here on the first and the second row, they're both true, but that's not the case on rows 3 through 8. So P ampersand Q is true on the first 2 rows, and then false on rows 3 through 8. Okay, now that we have this information, we can figure out the truth values for this conditional. P ampersand Q is the antecedent. Here are its truth values. R is the consequent. Here are its truth values. The only combination that makes a conditional false is true antecedent, false consequent. So that's what we're looking for. In other words, we're looking for any rows where P ampersand Q is true and R is false. And that combination occurs on the second row and no place else. So this conditional is going to be false on the second row and true on all the rest of the rows. Okay, now we're moving to what's basically an additional reference column. This is just the negation of P ampersand Q, so it's the opposite of what we have under P ampersand Q. So we'll have 2 F's followed by 6 T's. And finally now, moving to this disjunction, one disjunct's truth values are here under the negation of P ampersand Q. The other disjunct's truth values are here under R. The only combination that makes a disjunction false is when both disjuncts are false. And let's see, we've got that on the second row and no place else. So this is going to be false on the second row and true every place else. So, looking at the two statements we were testing for truth functional equivalence, you see that they have the same truth values on each and every row in our truth table. That tells us that they are truth functionally equivalent to each other. I hope this has been helpful for you. Let me know if there's anything I can do to help you understand the material better, and I'll talk to you again soon. Goodbye.